Hey guys, in this video I'm going to discuss example 5.17 and example 5.18. But before that I need to give you guys an idea about what is gamma integral. So let's just start. Right, so whenever you have a form which is like this, x to the power n minus 1 with the product e to the power minus x dx, this whole form is known as gamma integral. Right, gamma integral n. So the value of this is n minus 1 factorial, right? So let's just take an example, and this the limit should be from 0 to infinity, right? So for example, I have a term like x to the power 8 e to the power minus x dx from 0 to infinity, right? So we know that our form is x to the power n minus 1. So I'll be writing this as x to the power 9 minus 1 e minus x dx from 0 to infinity, right? So this is 9, right? 9 minus 1. So I have the same form as the above, so I can write this as gamma integral 9, right? Or I can display this as gamma 9, and the value of this is 8 factorial, right? So n minus 1 factorial, and we had n here, so n minus 1 factorial, this becomes 8 factorial, right? So now these two are the properties that you need to remember, right? This is the first property and this is the second property. Let me write this again. So let me show you guys. This is the first property that you need to remember, and this is the second property, right? So I'll be proving the first property right here, and you need to remember this, right? I'm not proving this property, you need to remember this, and now I'll be proving this property on the next slide. We just insert some slides. Right. So I am proving the first property now. So I'll be writing this, and this will be equal to, now x to the power n minus 1, right? But I have n plus 1 here, so I'll be writing this as n plus 1 minus 1 e to the power minus x dx from 0 to infinity, right? Let me show you again. So this was x to the power n minus 1. Whenever I have n minus 1 in the power of x, this is equal to gamma n. So now I have n plus 1, right? I have n plus 1 here, so I'll be having n plus 1 minus 1 in the power of x. So this will be equal to x. Now 1 and 1 will go, so this we'll be left with x to the power n e to the power minus x dx from 0 to infinity. From 0 to infinity, right? So yeah, so now I need to prove this. I'm proving something, the first property. I'm proving the first property here. So let's just apply isolate here. So taking out xn from the term, I'll be left with e to the power minus x inside, e to the power minus x dx minus the derivative of x to the power n with respect to x into the integral e to the power minus x dx, and now the limits, I'm writing my limits here from 0 to infinity, right? So this will give me, so this becomes x to the power n. Now e to the power minus x, the integral of this gives me, and my limits are 0 to infinity, minus this will become integral of 0 to infinity n x n minus 1, this is the derivative of x to the power n, and the integral of e to the power minus x is e to the power minus x minus 1, right? And now the integral of this whole term from 0 to infinity, right? So this is x to the power n, so just putting my limits here. Wait, so when I put the limits, this becomes this becomes 0, right? So e to the power minus infinity gives me 0, so this whole term will become 0 minus, now I need to put 0 here, so this gives me again 0, right? So this will become 0 into 1 plus, because this is a minus sign, we have a minus sign here in the denominator, so this will become 0, right? So this whole term, this whole first term is equal to 0, this whole term is equal to 0, right? And now playing with the second term, I can take out n, taking out n, this gives me 0 to infinity x to the power n minus 1, and minus minus goes away, this minus and this minus goes away, so I'll be left with, right? So let's just move to the next slide. So this gives me, the first term was 0, right? The first term was 0. Whenever I was substituting infinity, I was getting 0. Whenever I was substituting 0, I was getting 0, right? So the first term was 0, and there was a plus sign here, and this was n x to the power n minus 1 e to the power minus x dx. Now we know that this is gamma n, right? So we'll write this as n gamma n, right? So the property that we need to prove was gamma n plus 1 is equal to n gamma n. So I'll just show you, right? So if my n is 7, right, so n plus 1 is 8, so my gamma 8 is equal to n, and my n was 7, so this becomes 7 into r7, right? 7 into r7, and r7 is equal to 6 factorial, so this becomes 7 into 6 factorial, and this is 7 factorial, so 7 factorial is equal to 7 into 6 factorial, right? I can also write this as 7 into 6 into r6, right? So r6 is 5 factorial. See, remember this, rn is equal to n minus 1 factorial, right? So using this, I just wrote all of the terms. Now moving on, let's go to our first question, example 5.17. Let me just close my register. So my example 5.17 says a random variable x has the probability law dfx is equal to x upon b square. I am referring to this book, right? I'll be also putting the link to this book in my description. So this is x upon b square, and the product is e to the power minus x square upon 2b square dx, where x lies between 0 and infinity, right? So find the distances, find the distances between the quartiles, and show that the ratio of this distance to the standard deviation deviation of x is independent of the parameter b, right? So what's the formula for our quartiles? I'm just seeing the formula from the book. So the quartile is just q1 is my first quartile, right? Q1 is my first quartile. So 0 to q1 fx dx gives me the probability 1 by 4, and 0 to q by 3 fx dx gives me the probability 3 by 4, right? Yes, gives me the probability 3 by 4. Now this question says that we need to show that q3 minus q1 upon sigma, the standard deviation, this should be independent of b, right? This whole term should be independent of b. Let me just remove this. So let's just find the first quartile and then the third quartile, then the standard deviation, their differences, all of that, right? So let's just start 0 to q1. Now find the distances between parameter b. So usually I would have integrated this over the limit 0 to infinity to try and find b, but in the question they have specifically mentioned that q3 minus q1 is independent of the parameter b, right? So I don't think we need to find b here. So I'm not checking that if it's a valid PDF or not. It's a good practice. I've done that in the previous videos, but I won't be doing that here. Right. My seat is uncomfortable. So just taking out b square outside. This is my PDF. X upon b square e to the power minus x square upon 2b square, right? Let me just write this clearly. So my PDF is 0 to q1 x upon b square e to the power minus x square upon 2b square dx, where my x lies between 0 to infinity, right? But we need to show that this is equal to 1 by 4 to find q1, right? Quartiles are just they just divide the whole distribution into parts of 4, right? So if this is the first quartile, so the area under the curve before this will be 1 by 4. So this is 1 by 4. Now this is q2, so this will also be 1 by 4, right? This will also be 1 by 4 and 1 by 4 plus 1 by 4. So the total area from 0 to q2 fx dx will be equal to half. q2 is also the median. Here. And q3 is again 1 by 4. This is again 1 by 4, right? So this whole becomes 1 by 4 plus 1 by 4 plus 1 by 4. Hence 0 to q3 fx dx gives me 3 by 4. It's just the probability, right, before q by 3. This is equal to 3 by 4, or the area under the curve from my lower limit to q3 is 3 by 4, and here my lower limit was 0, right? So this is 3 by 4. Now, and q4 will be this q4. This is again 1 by 4. So 4 times this is 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4, and we know that 4 times 1 by 4 will give me 1. So 0 to my lower limit, it can be anything, right? It can be minus infinity also, but I am taking the lower limit to be 0 here, or let me just take it minus infinity. It will be better because in the previous parts I've taken 0. So let me just take the lower limit as 0 only. So 0 to q by 4 gives me fx dx is 1, right? Is 1 or 4 times 1 by 4. I am just removing all of this now. This was only to explain you guys what are quartiles. Let me use my eraser. I don't know why I'm not able to erase this. Let me just jump question now. So I'll be just taking out b square because it's a constant term. So 0 to q1 x e to the power minus x square by 2b square is equal to 1 by 4. But I'm not writing 1 by 4 here. I'm just solving this integral first. So I need to apply isolate here. Or what I can do is that I can substitute this. So x upon x square upon 2b square can be t. So this becomes 2x dx by 2b square is equal to dt, right? 2x dx upon 2b square is equal to dt. So this gives me x upon b square dx is equal to dt, right? I just differentiated this. So x upon b square dx is equal to dt. Now when my x goes to 0, my t, which is x square upon 2b square, goes to 0. When my x goes to q1, my t, which is x square upon 2b square, goes to q1 square upon 2b square, right? So my limits have changed when I'll be substituting t here. So my whole term will become, so I'm just including this b square here. It'll be easy for me. So x upon b square becomes dt. So let me just write this whole again. So my x square upon 2b square was t. My t is going from when my x goes to 0, my t goes to 0. When my x is going to q1, my t is going to q1 square by 2b square, right? And now and now my integral, which is from 0 to q1 x upon b square. Now I've just taken the b square inside so that my whole calculation comes easier. X upon b square, it was x upon b square e to the power minus x square upon 2b square, right, dx. This was my whole integral. So this becomes x upon b square, right? So x upon b square, yeah. So this becomes 2x, this becomes 2x dx upon 2b square. 2 and 2 gets cancelled, so I'll be left with x dx upon 2 x dx upon b square. X dx upon b square is equal to dt, right? So now I'm just substituting x upon b square. This is dt. So this whole term x upon b square dx becomes dt, and this is e to the power minus t. So this becomes e to the power minus t, e to the power minus t dt by 2. I have no, not by 2. This is e to the power minus t dt from 0 to q1 square by 2b square, right? This should be equal to 1 by 4. Let me just check. So what we have done is correct. Yes. So this becomes e to the power minus t becomes e to the power minus t minus 1, and limits are 0 to q1 square by 2b square, and this gives me, substituting, this gives me minus, I am just taking out minus from here. This gives me minus q1 square by 2b square e to the power minus q1 square by 2b square minus, now if I just substitute 0 here in place of t, this gives me 1, so this becomes 1. So this gives me 1 plus 1 1 minus e to the power minus q1 square by 2b square. Let me go to the next slide. So this gives me 1 by 4. So this becomes 3 by 4 is equal to e to the power minus q1 square by 2b square. So I'm just taking log here. This becomes log 3 by 4 is equal to minus q1 square by 2b square. Just taking log on both sides. Right, so ln of e to the power x or minus x, just x gives me x only, right? So I just took log here, or let me write ln here. So I just took ln 3 by 4 and this gives me minus q1 square by 2b square. Right, so this becomes minus ln 3 by 4 is equal to q1 square by 2b square, which implies q1 square is equal to minus ln 3 by 4 into 2b square. If I just take this minus 1 inside, this becomes log 4 by 3 into 2b square. So this gives me, now q1 is root of this whole term and b will come out. Let me just go to the next slide. So this will give me q1 is the root of this whole term, the root of, now I'm ignoring the plus minus, right? I would be having two cases here, but I'm ignoring the negative because my x lies between 0 to infinity, right? So my q1 will also will be between 0 to infinity, and also we know that log 1 is 0, ln 1 is 0, and therefore ln 4 by 3 will be greater than 0, right? So this is positive, right? And b square is also positive and 2 is also positive, right? So this whole term is positive, right? So q1 is, so I'll be ignoring the negative here. This gives me, b will come out of the root sign. This will become 2 log 2 ln. Let me just change this to ln. Log is also fine, but no, I should be writing ln here. The base is e. I can't write log. So this becomes, right, so this is 2 ln 4 by 3 positive. This is my q1. Let me just check if I'm right, or is there any simplification here. So this gives me right, so they have written it like this: q1 is equal to b root 2 root ln 4 by 3. They have written log, they have taken the base as 10, I guess. B root 2 log 4 by 3. I have taken ln. I think they should have used they should use ln here, right? So q1 is clear. Now I'll be finding out q3. Similarly for q3, I'm just writing the steps here. For q3, it will be from 0 to q3. For finding q3, let me go to the next slide. My handwriting is, anyways, very poor. I can't afford to write a lot on one slide. Right, so my weight is defined. Yes, let's just proceed. So now we need to find q3. For q3, I should be having fx, this is 0 to q3, fx dx should be equal to 3 by 4, right? q3. So this becomes 0 to q3 x upon b square e to the power minus x square by 2b square dx, which, you know, after substituting x square by 2b square as t and just, you know, differentiating this gives me x dx by b square as dt. So just putting it, and my t goes from 0 to q3 square by 2b square, right? q3 square by 2b square. Why? My because my x goes from 0 to q3, right? So let me just erase all of this now and write this in a more dignified way. Just remove this. So when my x goes to 0, my t goes to 0, my x goes to q3, my t goes to q3 square by 2b square, right? So I'm just, you know, skipping one step, so I can write this as e to the power minus t dt when t goes from 0 to, actually I did all of the steps. q3 goes from t goes to from 0 to q3 square by 2b square, right? q3 square by 2b square, right? I'm just substituting q3 here. q3 is 0 to q3 square by 2b square. So now when I'll just put in the limits, I'll be left with 1 minus e to the power minus q3 square by 2b square, the same form. The same form, right? 1 minus q1 square by 2b square, this form I'm talking about, this form. So now I'm left with 1 minus q3 by 2b square is equal to 3 by 4. So this gives me 1 by 4 is equal to e to the power minus q3 square by 2b square. Moving to the next slide. Taking log on both the sides gives me ln 1 by 4 negative this gives me q3 square by 2b square, right? So this becomes ln 4. I'm just taking this in. So this is a property, n ln x is ln x to the power n. So if I have minus 1 here, minus 1 ln x gives me ln x to the power minus 1, which becomes ln 1 upon x, right? Just remember this. So this becomes q3 square by 2b square, which is q3 square into 2b square ln 4, which is q3. Now I'll reject the negative value, so this will give me root 2b root ln 4. I'm just writing how they have written in the book. That's why I'm taking, you know, separate roots here, writing it separately. So this is b is not in any root. Let me just write b outside. So this is how they have written it, like, yeah, b root 2 ln 4, b root 2 ln 4 or log 4. We have q3, we have q1. Now we need to find the standard deviation, because we need to compute this term q3 minus q1 upon sigma. This should be independent of b. So for this we need to find sigma. And what is sigma? Sigma is the standard deviation. And what is the standard deviation? Standard deviation is the second moment with respect to the origin minus the first moment minus the square of the first moment with respect to the origin. So my sigma, this is my variance, and so sigma square or variance is equal to the second moment with respect to the origin minus the first moment with respect to the origin, the square of this, or I can write this as ex square minus ex whole square. This gives me sigma square. Then I'll find the root and I'll get the standard deviation. So sigma or root variance or root sigma square is the standard deviation. Right? So this gives me sigma square. Now I'm finding sigma square. For sigma square I need to find the second moment with respect to the origin, ex square. So for finding the second moment with respect to the origin, now we'll use gamma integrals here, right? So for finding the second moment with respect to the origin, I need to find x square fx dx from 0 to infinity, because the limits that we had for x were x lies between 0 and infinity, and gamma integral also works between 0 and infinity, right? I just explained it in the first part of the video. So 0 to infinity, I can write the PDF now. The PDF was x upon b square e to the power minus x square by 2b square dx, right? I need to apply gamma integral here, and gamma integral says that whenever you have the limits are 0 to infinity and the form is x to the power n minus 1 e to the power minus x dx, something like this, you can straight away apply n minus 1 e to the power minus x. Let me just write this clearly. And gamma integral says that whenever you have the limits are 0 to infinity x raised to the power n minus 1 with the product e to the power minus x dx, this gives me gamma n. Right? So now moving forward, so I had x square into x right here, so I can write this as, so this becomes x cube, this becomes x cube upon b square e to the power minus x square by 2b square dx. I need to find a way to apply the gamma integral here. What can I do here? So my x square or 2b square, substitute it as t, and when x goes to 0, t goes to 0, when x goes to infinity, t goes to infinity, right? So this gives me 0 to infinity. Now I'll be writing this as x, if I just differentiate this gives me, again I did this previously, 2x by 2b square dx is equal to dt, where my dt ultimately is equal to x upon 2b square. So my x upon 2b square will go away as dt, x upon 2b square dx, this whole term will become dt. Let me write this clearly. So my whole term x, this is x square, right? I am left with x square. Now this is e to the power minus x square by 2b square, and I have another x upon b square here. There is no 2 here, right? 2 and 2 were cancelled, so there is no 2 here, right? So my this whole term x upon b square dx is equal to dt. X upon b square dx is equal to dt, right? This 2 and 2 goes away. X upon b square dx is equal to dt. So this whole term becomes dt. So moving to the next slide, I'll be getting the second moment with respect to the origin is 0. Now my limits are from 0 to infinity. So 0 to infinity. T is also going from 0 to infinity. So 0 to infinity. Yeah, so I'll be left with this is x square, and e becomes, wait, if I have x square here, and we know that x square is equal to 2b square t. I'm just taking 2b square here, so x square is also 2b square t. So I'll be writing this as x square I'll be replacing this x square with 2b square t. This becomes 2b square t, and this whole term becomes e to the power minus t dt, right? So this is 2b square t to the power minus e dt. So this becomes, now taking 2b outside, this gives me 0 to infinity 2b square outside. I'm just taking 2b square outside. This becomes t e to the power minus t dt, which gives me this as 2b square, and this becomes gamma. Now my power of t here is 1, so 1 is equal to my 1 here is equal to n minus 1, right? My 1 is n minus 1, therefore my n becomes 2. So this becomes gamma 2, right? 1 and 1 goes here, so my n becomes 2, n minus 1 t. Or I can write this as, just to explain you guys again, 0 to infinity t 2 minus 1, I can write 1 as 2 minus 1 e to the power minus t dt, which gives me 2b square, and this is gamma 2. So my second moment with respect to the origin, now gamma 2 is equal to n minus 1 factorial. Gamma 2 is, this is different. I am just trying to write this. Gamma 2 becomes n minus 1 factorial. Yeah, so my n is 2, so this is 1 factorial. This term gamma 2 is equal to n minus 1 factorial or 2 minus 1 factorial, which gives me 1 factorial, and 1 factorial is equal to 1. So this whole term becomes 2b square, right? So my second moment with respect to origin becomes 2b square. Again, this whole term became gamma integral that I shared with you guys earlier in the first part of the video. This became 2b square gamma 2, and gamma 2 is equal to 1 factorial, right? So this became 2b square. So my second term with respect to the origin, my second moment with respect to the origin is 2b square. My second moment with respect to the origin is 2b square. Done with this. Now I need to find the first moment with respect to the origin. This should be equal to 0 to infinity x fx dx. Now my x here is x into my fx is x upon b square e to the power minus x square by 2b square dt from 0 to infinity, substituting x upon x square upon b square, this term as t. This gives me d x upon b square as t. This gives me x upon 2b square as t. I have 2 here, so this gives me 2x by 2b square dx is equal to dt. The derivative of t is dt, so 2 and 2 gets cancelled, so x upon b square dx is equal to dt, right? um, I shouldn't be explaining you guys this, but whenever we have a function here, like for example I have t here and I had x here, so I was writing this as dt and this as dx, right? This was not derivative, this was this, I don't remember the term for this. This is I don't remember the exact term, but this is the total derivative, or there is a property, there is a specific property in calculus. I'll be sharing this with you, which says that you can just find the derivative. This is not the derivative exactly, but this is not the derivative. For example, this is t and I say that find the derivative with respect to x, so the derivative will be dt dx, right? For example, I have t square and I need to find the derivative with respect to x, so this will become the derivative with respect to x, this will become 2t dt upon dx, right? But this is the total derivative. When I talk about writing this t as dt, or I have x square here, so I am just writing this as, I can write this as dt is equal to 2x dx, right? So this is not with respect to any term or any other variable. I am just writing this, the derivative of this whole function, right? I am not derivating or using another function to find the derivative here. I am just finding the total derivative of the original function only, right? So if I say I need to find the derivative of this using this, I'll be finding dt. I need to find dx by dt, right? If I need to find dx by dt, so dx by dt will become here as this is dt and this is 2x dx. So this will give me dx by dt. I need to find dx by dt, so this will become dx by dt and 1 upon 2x, right? Or if I need to find dt by dx, so this will become 2x. But when I write it, when I write this in this form, I am finding the total derivative. I don't know the exact term. This is part of calculus, but you should remember that this is the total derivative. But I need to check for the exact term here. You can just skip this. Right, so we found this term here, yes. So we just found this term, x upon b square dx is equal to dt. X upon b square dx is equal to dt. Now I'll be just substituting it, and when x goes to 0, my t, which is x square upon 2b square, goes to 0. When my x goes to infinity, my t goes to x, my t, which is equal to x square by 2b square, goes to infinity. So my final function becomes, I had this 0 to infinity x upon b square e to the power minus x square by 2b square dx. Now my x upon b square dx becomes dt, right? X upon b square dx is equal to dt. So this I'm left with, now see, I'm left with x only, right? If I write this as x, if I write x upon b square dx as dt, and my minus x square upon 2b square is t, so I'll be left with 1x here. So I need to find the value of x with respect, I need to find the value of x in terms of t, so that I can write the whole integral in terms of t. So for finding x only, x square is 2b square t. Earlier in the previous question we needed to find the value of x square, so I just substituted this in the integral and I found it by applying gamma. So this becomes x is equal to t to the power half root 2b, right? So this x becomes 0 to infinity root 2b t to the power half into, now this x upon b square dx is dt, and this is e to the power minus t dt. So I'll be left with 0 to infinity root 2b comes out, this root 2b comes out, and I'm left with 0 to infinity t to the power half e to the power minus t dt. So I can write this half as, this is root 2b 0 to infinity. I can write this t to the power half as t 1 minus I can write this as I'm left with half, so I need to write n minus 1 is equal to half. N minus 1 is equal to half, so n becomes 3 by 2. So this becomes t 3 by 2 e to the power minus t dt. 3 by 2 minus 1, wait, let me just go to the next page. So I'm left with this term, just remember this term. So this becomes root 2b 0 to infinity t to the power half e to the power minus t dt. So this gives me root 2b. Now I should have t to the power n minus 1 and e to the power minus dt 0 to infinity like term. I need to find create a term like this so that I can write this as gamma n. Now for finding n minus 1 should be equal to half. So this gives me n is equal to 3 by 2. Just taking 1 to the RHS, this gives me n is equal to 3 by 2. So I'll be left with 0 to infinity t to the power 3 by 2 minus 1, which is equal to half, which is same as half, and this gives me e to the power minus t dt. This whole will become equal to r 3 by 2. Now what should we do? R 3 by 2, how do we find the value of this gamma r 3 by 2? This is so how do we find the value of gamma 3 by 2? So I proved one property. The property that I proved was Rn is equal to Rn plus 1 is equal to n Rn, right? And I also told you guys to remember one property, which is R half is equal to root pi. Let me just take you guys to the first part of the session. Rn plus 1 is equal to n gamma n plus 1 is equal to n gamma n, and gamma half is equal to root pi. I told you guys to remember the second property. I am not proving that. So yes, so this gives me gamma half is equal to root pi. So now proceeding ahead, gamma 3 by 2, I need to write this in terms of gamma half. What is gamma 3 by 2? What does gamma n say? Gamma n is n minus 1 factorial. So gamma 3 by 2 is 3 by 2 minus 1 factorial, which is half factorial. So gamma 3 by 2 is equal to half factorial, or I can write gamma 3 by 2 as n plus 1, and n plus 1 is half plus 1 is equal to 3 by 2. Half plus 1 is equal to 3 by 2. So gamma n plus 1, or let me write this as 1 plus half. So this is half plus 1 is equal to 3 by 2. So gamma n plus 1 is equal to 3 by 2. which gives me n gamma n, n gamma n. My property was n gamma n, so I can write this as, just removing n now, my n is half, so this will give me my gamma 3 by 2 is half gamma half. My gamma half was root pi, so this becomes root pi by 2, root pi by 2. So my gamma 3 by 2 is equal to root pi by 2. Therefore my first moment with respect to the origin is root is b root 2 root pi by 2. 2 and 2 goes away. I will be left with this root 2 and 2 gets cancelled. I will be left with root pi by root 2. Let me just check if I am right here. The first moment is equal to, yes, and my second moment was also 2b square, was 2b square. Was it 2b square, my second moment with respect to the origin? Yes, 2b square, right? See, 2b square. So my variance x, or my sigma square is, or the square of this, which is ex square minus ex, if I write this in expectations term, so this gives me sigma square as my second term with respect to the origin. So this was 2b square minus the square of b root, I just took 2 inside the root 2, just writing this like this. So this gives me sigma square as 2b square minus b square pi by 2. This gives me, taking out b square common, this gives me 2 minus pi by 2. So sigma becomes my standard deviation, or root of sigma square, the root of this whole term is equal to b square root 2 minus pi by 2, which is equal to b root 2 minus pi by 2. So my sigma is equal to, standard deviation is equal to b minus pi by 2. Now I have my standard deviation, I have my q3, q1. What I'll be left with is, now I need to find, I need to just show you guys that q3 minus q1 upon sigma is independent of parameter b, is independent of b, right? So my q3 is, my q3 was, my q1 is this, my q3 was b root 2 ln 4, and my q1 was b root 2 ln 4 by 3. q1 is b root 2 ln 4 by 3 and b root 2 ln 4, right? So q3 is b root 2 ln 4 and q1 is b root 2, just now, and my sigma is so q3 minus q1 by sigma, q3 minus q1 by sigma is equal to b root 2, just taking b root 2 common, from this gives me ln 4 minus ln 4 by 3. I just subtracted this and took b root 2 common, this gives me, and I have another b here, and this is root 2 minus pi by 2. So So b and b gets cancelled. We needed to prove this only, that it's independent of b. So b and b gets cancelled. So q3 minus q1 by sigma gives me this becomes 4 minus pi, just taking the LCM, 4 minus pi, just taking the LCM here, 4 minus pi by 2, and this whole is ln 4 minus ln 4 by 3. So I can write this as ln 4, and ln 4 by 3, I can write ln 4 by 3 as ln 4 ln m upon n is equal to ln m minus ln n. So this becomes ln 4 minus ln 3. So my q3 minus q1 by sigma is root 2, and my this root 2 goes above, so I'll get 2 here, 2, and ln 4 and ln 4 goes away, so I'll be left with 2 ln 3 by root 4 minus pi. I need to check if my answer is right. 2 ln 3 root 4 minus pi. So they, I made a mistake. I made a very bad mistake. Let me just cut this off. I forgot to put root here. There was root also here. Right, so there was one root also here. Root, I just forgot to put the root here. So my final answer will be till here only. Or I can do that. So I can, if I try to simplify, I just leave my answer to here only. They have also left their answer as this only. So wait. So they have left their answer here only. So this is root 2. This is root 2 root ln 4 minus root ln 4 by 3. They have also left their answer to here only. I just forgot to put the roots. So, and this becomes 2 minus pi by 2, which is independent of parameter b. Right. Yes, so let's just start with example 5.18. Example 5.18 says that df, example 5.18 says that df is equal to y naught e to the power minus mod x dx, where my x lies between minus infinity to infinity. Show that y naught is equal to half. My first moment with respect to the origin is 0, and my sigma is root 2. Also show that my mean deviation about mean is equal to 1. So I need to show that y naught is equal to half. My first moment with respect to the origin is 0, and my standard deviation is root 2. Also that the mean deviation about mean is 1. So firstly, for finding y naught, I need to integrate the PDF over the limits minus infinity to infinity. So minus infinity to infinity, integrating the PDF, just taking out y naught from the integral because it's a constant term. So my e to the power minus mod x, my function, let me just write fx is equal to e to the power minus mod x, right? So if I substitute f of minus x here, this gives me minus x here, which means this becomes a negative sign in mod doesn't matter. This gives me, right? So my fx is equal to f of minus x. This means that this implies that fx is an even function, and we know that the integral of an even function from the limits minus a to a, where a is any real number, from a minus a to a, fx dx, where fx is an even function, can be written as 2 0 to a fx dx, right? So now let's just solve this. Y0 was outside, minus infinity to infinity, and e to the power minus mod x, and e to the power minus mod x is an even function, so I can write this as 2 times 0 to infinity e to the power minus, now when x lies between 0 to infinity, minus x mod x will be just x, so this will become e to the power minus x dx, which will give me y0 2 times, which is e to the power minus x minus 1 0 to infinity, and this should be equal to 1 because I'm integrating the PDF. So this gives me, and this is just taking the negative sign outside, this gives me minus infinity minus e to the power 0, which is equal to 1. So this gives me minus 2 y0, this is 0, this is minus 1, the minus 1 is equal to 1, which implies that this negative becomes positive, y0 is equal to half. Right. So now y0 is equal to half. Now I need to find the first moment with respect to the origin. This should be equal to 0, therefore ex is equal to 0. So finding the which is equal to ex is equal to x fx dx minus infinity to infinity. Now I know that minus infinity to infinity x into fx is e to the power minus mod x dx, right? So now my gx, let my function be gx, so gx is x e to the power minus mod x, right? And if I substitute negative x here, so this gives me negative x e to the power minus, now negative x doesn't matter in the domain, so this in the mod sign, this gives me, yes, so my gx is equal to, so my g minus x is equal to the negative of g of x, which implies that gx is an odd function. Also we have a property that any function gx, any odd function when integrated, for example gx, any odd function when integrated from minus infinity to infinity, from minus a to a, any odd function when integrated from minus a to a is equal to 0, right? So this implies that minus infinity, this is the property of definite integrals, so minus infinity to infinity x e to the power minus mod x dx, this is equal to, this is x e to the power minus x, this is equal to 0. This implies that my first moment is up to the origin, or my mean expected value of x is equal to 0. We prove this also, we need to prove this only, na? See, this is 0. Now we need to show that my sigma is root 2. We need to show that the sigma is root 2. we need to show sigma is equal to root 2. For finding sigma, I need first I'll be finding sigma square. So sigma square is the second moment with respect to the origin minus the first moment with respect to the origin, the square of that. So let's just move to the next slide, or let me just show you something. So my second moment with respect to the origin is e x square, and this is equal to x square fx dx from minus infinity to infinity. Now let me write so this my second moment with respect to the origin was minus infinity to infinity x square fx dx. So this was x square e to the power minus mod of x dx dx from minus infinity to infinity. So my hx, a new function, I'm defining a new function, is x square e to the power minus mod x. So this becomes, if I put substitute a negative x in place of x, this gives me, so negative the square of this negative x, and e minus x. This, I told you that a negative sign in the mod doesn't change anything. So this gives me x square, the square of a negative sign is positive, so x square e to the power minus mod of x, right? So my h of x is equal to my h of minus x, which implies that h of x is an even function, and any even function hx from minus a to a dx is equal to 2 times from 0 to a. I can write this as, this is a property, hx, I told you this before also, hx dx. So I'm just writing this as, my second moment with respect to the origin becomes 2 times 0 to infinity x square e to the power minus mod of x dx. So this yeah, and also when I'm writing x, I'm defining this function from 0 to infinity. I can write this mod of x e to the power minus mod of x as e to the power minus x only, because my x is always positive. So I should have written that only in the first place. So this, see, my x is always positive from 0 to infinity, so I can write this as e to the power minus x only. There is no negative sign coming outside, so this just becomes x square. Now I already had a negative sign here, and x is already positive, so mod of x is equal to, see, the definition of mod of x says that this is x when x is greater than 0, like we have here in this case, and this becomes minus x when x is less than 0, right? So our x was positive here, so only x came out of the mod. I'm just moving this now. So this becomes 2 times 0 to infinity x square e to the power minus x dx. So I can use gamma integral here because my limits are 0 to infinity. So I can write this as 0 to infinity. So this should be n minus 1. So 2 is equal to n minus 1. 2 is equal to n minus 1. This gives me n as 3. So I can write this as x 3 minus 1 e to the power minus x dx, which gives me 2 times gamma 3. 2 times gamma 3. Times gamma 3. This is 2 times gamma 3. 2 times gamma 3 is 2 times gamma 3, and gamma 3 is equal to 2 factorial. N minus 1 factorial is 2 factorial. So this is 2 factorial. So this becomes 4. So my mu 2 becomes 4, and now my sigma square is, and this was 0. I calculated this previously. So this gives me this has 4, so my sigma is 4. Wait, I did something wrong. So my sigma becomes, sigma is 2. It's coming out to be 2. Wait, I've done something wrong. Oh, I ignored y naught here, right? So just see here, I ignored one y naught term here. I ignored the term here. Wait, I had to write y naught also here, right? This y naught also. So y naught came outside. This half is also outside, right? So just integrating this gives me a half, another half here. There was a half here. The y naught term was outside, so this becomes this. So this gives me my mu 2 dash as 2. So this gets cancelled. This gets cancelled, right? This gets cancelled. So this gives me only I'm only left with 2 factorial. I'm only left with 2 factorial. So this gives me 2 factorial is 2. So this means that my variance is 2. My variance is 2, right? Variance is 2. 2 minus 0. This is 2. So this is 2. So sigma becomes root 2. What we had to prove. Just what we had to prove. Sigma is root 2. So what I did wrong was I ignored this term, y naught term, right? We had calculated earlier that y naught is half, and our PDF says that our PDF is y naught into e to the power minus mod of x. So I ignored y naught, but when my answer wasn't matching, I multiplied it by y naught. So this becomes sigma. This gives us sigma as root 2. Now we need to find mean deviation about mean, right? Mean deviation about mean is 1. About mean is 1, right? So our mean is 0 here. Our ex or our first moment respective region is 0. So our mean deviation, which should have been like this: x to the power minus mod of x minus mu fx dx from minus infinity to infinity. This will become because this is 0, mu is 0, so this gives me x mod of x. Fx is taking out half outside, y naught outside. This is minus of mod of x dx from minus infinity to infinity. Now my mod of x e to the power minus mod of x. So let me define this by another variable, m of x. This is my new function, m function. M of x is mod of x e to the power minus mod of x. So when I substitute minus mod of x, this gives me minus mod of x. This will remain as x. So this gives me minus, and I can ignore the negative sign in the mod. This gives me mod of x e to the power minus mod of x. This negative sign was outside, so this will remain as it is. So this implies that my m of x, my m of negative x is equal to my m of x, which implies that mx is an even function. So we can write this even function as, I'm just writing the even function as 2 times from 0 to infinity. So I can write this as, my mean deviation as, I can write my mean deviation as 0 to infinity 2 times. I just from minus a to a becomes 0 to a, and I multiplied by 2, so this becomes 2, 0 to infinity mod of x e to the power minus mod of x dx. This gives me yeah. So and my x is lying between 0 to infinity, so this will become x, and this will also become x because my x is positive here. So I'll just write this as 2 from 0 to infinity x e to the power minus x here dx, because my x was positive, and we know that mod x is equal to x when x is greater than or equal to 0, and minus x when x is less than 0. But in our case we have x greater than 0, so it will become just x, right? So mod of x becomes x, and e to the power minus mod of x becomes e to the power minus x. So just removing all of the mod sign, wait, this was e to the power minus x dx, right? So this becomes, now here my n minus 1, here I have 1 power 1, so my n minus 1 is equal to 1, so n becomes 2, therefore this 2 times, and I also had one y naught outside, I again missed y naught, right? I had y naught outside, y naught is equal to half, so this 2 and 2 gets cancelled, this 2 and 2 gets cancelled, so let me just skip writing the 2 here, this is already cancelled, so this gives me the mean deviation as, my mean deviation is equal to, my mean deviation is just 1 into this x to the power, so I can write this as, I can write this one as 2 minus 1 e to the power minus x dx from 0 to infinity, which gives me 1 into my gamma term, my gamma 2 gamma n, it should be, right, this is equal to gamma n, my 0 to infinity x n minus 1 e to the power minus x dx gives me gamma n, so this becomes gamma 2, and gamma 2 is 1 factorial, n minus 1 factorial, so this is 1 factorial, so this is 1 factorial, 1 factorial is equal to 1, 1 into 1 factorial is 1, and 1 factorial is also equal to 1, so mean deviation is equal to 1. So we proved all the parts. In some steps I missed writing y naught, you shouldn't do that, it will create an unnecessary error, right? So we need to prove that, y naught is half, we did that, the first moment with respect to the origin is 0, we did that, we proved that our standard deviation is root 2, and we proved that our mean deviation about mean is 1. Thank you guys for watching this video, I hope you guys like it, and please do share, like and subscribe the channel if you want more such videos. Also, if you think that I have made some mistakes, please correct me in the comments. Also, if you have some suggestions or anything else you want to add, any proofs you want me to take up next time, I'm going to start taking up proofs, but I'm just trying to focus on questions first, and then I'll be taking starting with the proofs. Also, in the first part of this video, in the before the example 5.17, I covered gamma integral, so I hope you guys understood it, and if you have any doubts, just ping me in the comments. Thank you, and I hope to see you in the next video.